So I want to show you one more example. This one's a little bit different, and hopefully this process of using the conservation of energy will kind of sink in after I do a second example. So the first thing that you're going to do is you're going to always start by reading the problem and then drawing a quick picture to visualize what's happening. So a safe is hurled down from the top of a 1.3 times 10 to the 2 meter building at a speed of 11 meters per second. What is its velocity as it hits the ground? So in this example, the safe is starting, but this time it's not dropped. It's hurled down to the ground with a velocity of 11 meters per second. So I'm visualizing the safe in the air when it's initially thrown, and then I'm visualizing the safe when it hits or right before it hits the ground. So after I visualize that, then I'm going to write down the types of energy that I know that the safe has. So because the safe is thrown at a velocity of 11 meters per second, I know that it has to have kinetic energy because it has a velocity. I also know that the safe has a height, so it has potential energy. At the end, right before it hits the ground, I know that my height is 0, so my potential energy is also 0. But I know right before it hits the ground, it will have a velocity, so it's going to have kinetic energy. So then what I'm going to do is I'm going to use the conservation of energy to solve for the velocity when it hits the ground. So I know the conservation of energy states that my total energy initially is going to equal my total energy at the end. So initially, the object has this type of energy. It has potential plus kinetic. And I got that from my diagram. At the end, I know that there's a height of 0, so it has no potential energy. It only has kinetic energy. So then what I'm going to do after that is I'm just going to sub in the equations that I know. PE equals mgh. KE is 1/2 mv squared. And KE is 1/2 mv squared. Then I'm going to cancel out my mass because it's in every term. And I'm going to plug in the numbers I know. G is always 9.8. My height is the height that they give me in the problem, 1.3 times 10 to the second times 0.5. V squared is 11 squared. Then I'm going to simplify everything. So when I simplify this, I can do 9.8 times 1.3 times 10 to the 2 will give me 60.5. The 0.5 times 11 squared gives me 1274. And that leaves me with 0.5 v squared. Then I can simplify these, and I get 1334.5. I can divide both sides by 0.5. V squared equals 2669. And then I'm going to square root both sides. V is equal to 51.7 meters per second.